Hey everybody, it's Ben here, and I just built my own remote control system that integrates my home automation system with my electric car charging, and I want to show you how you can build it too. I was recently inspired by a friend's project where he put together a box with a contactor, a mechanical timer, and a hacked remote control so that he could turn his electric car charging on and off with either that remote or that timer. And I thought, well, wait a minute, I've already got a home automation system. I'm using the Samsung SmartThings system. So I thought, well, why don't I integrate that with electric car charging? So this is what I came up with. So let's take a look at the components, and then I'll take you step by step through the process of building this. On the outside, it's a 8-inch electrical project box. We've got a simple little power indicator, a multi-purpose gauge, a Leviton Z-Wave smart switch, a NEMA 1450 electric outlet, and a NEMA 1450 appliance cord. Inside the box, we've got a contactor. And that contactor, the coil is 120 volts, and it's controlled by the switched output of the switch. So by turning the switch on and off, it opens and closes the contactor, which is the power to the outlet, and it turns the EVSE on and off. So now that we know the basics, let's go in and we'll go through step by step of actually building the project. So in front of us here is the lid of a 8-inch junction box, and I've put my various components on here, and it looks like they should all fit okay. I have my home automation control switch, a 40 amp contactor, a 240 volt NEMA 1450 electric outlet, a power indicator light that's designed for 120 volts AC or DC, and a little multimeter with connections for both power and for a current shunt. So that's how it's going to measure the power used. And all I'm really trying to do is just get everything to fit together on here and keep it far enough away from the edge of the box that I can make all my wiring connections. So for example, that contactor I really can't have all the way down at the bottom, or I won't be able to use these electrical connectors here. So I'm going to move that up a little bit closer to the middle of the box. So I'm going to lay these out, space them, and then mark where I need to cut. And so for example, with the electric outlet, what I'll do is I'll use the cover that would normally go on there and just use it as a template down in the corner here. And then I'll cut a 2 1/8 inch hole right there. I just realized that I want this power indicator light to be centered, in the same column with this. So what I'm doing is just take a speed square, line it up with the edge here, and then draw a line straight up from the center of that cutout. And then that way, the hole for the power indicator will center on that same line right there. Then I also want this centered up with our power indicator light. So I'll put this about where I think I want it to go. Mark the center. Now I know exactly where to put that power indicator, and then I'll center this on that same line. Seven-eighths hole, and that'll be right through there just like that. And of course that'll get a nut to hold it in place when we're all done. I just realized that this hole saw either has no centering bit or it got lost, but it's about a 3/16 hole, so I'm going to drill a 3/16 hole here so I can run a bit through for centering that. So with the electric outlet and power indicator in place, I still want to figure out where I want my display, and the home automation smart switch, and then the contactor, you won't see it because it'll just be on the inside, but that's going to go about there. So I'll have to cut some holes for these. So all I'm going to do is center this on the line coming off from this hole and make sure it's square. So I've got the NEMA 1450 power indicator, multimeter display, and I still need room for the switch and for the main contactor. So basically I'm going to put the main contactor about here, and the switch I need it to fit in here. So it looks like it's going to line up right about here. So right here, all I'm doing is just making sure that none of the components overlap, just spacing them out to make sure I know where to mark the holes for the contactor. A lot of the rest of this now is just a matter of putting in some screws to hold the devices in place. With the contactor and the NEMA 1450 electric outlet screwed to this faceplate panel, I can start wiring it up. Here I'm using some heavy 6-gauge wire, and on this red hot wire I'm going to slide the current transducer for the display so we can measure current on over the wire before connecting it up. And then after that, the other hot lead, the black wire between the NEMA 1450 and the input side of the contactor. Next are some skinnier wires to go from the contactor up to the display meter. I'm using 14-gauge wiring here and just crimping a solderless spade connector, female spade, on the end that can plug right into these convenient connectors on the contactor, and that goes to the meter. On the back of the meter, it has a little diagram indicating which wires go where. Of course, the skinny wires there are connected to that current transducer. The other thing I found out with these is it's not obvious which way is up. So look on the front, the little button is on the right-hand side. Don't install it upside down. The two power wires come up from the contactor, and then the current transducer is just on that one heavy red wire on the output end of the contactor. And what that does is it means we're only measuring the power from the contactor, not the meter or the light that I'm going to add or anything else. And we just have to turn the meter to get it through the hole, and then we can pop it down into place. And it's starting to look like something. And of course, various components need to be grounded, so I'm going to use this ground bus bar. I'm going to mount it right here, and then the ground from the switched outlet, the ground from incoming power, and the ground from the smart switch can all plug into there. drill a pair of holes for those. Next, I'm adding the ground to the NEMA 1450 outlet. This is a heavy gauge wire and it's solid, so I pre-bent it with the pliers to make a shape that fits here, and then tighten down the connector on the outlet and the ground bus bar. So here's the installed ground bus bar. I'm also over here going to add a bus bar for all the neutral connections. So I'll mark those, drill them, and bolt them down just like I did for the ground bus bar. Now up at this power indicator light, that's 120 volts. So what we'll do is we'll tap off this switched black hot wire to send power to it, and then to complete the circuit we'll use a neutral wire coming back to the neutral bus. So keep in mind the contactor is switched, so we'll have switched power, but it's going to be 120 volt power to the indicator light, which will show us whether or not there's power to the 240 volt electric outlet. So one short black wire from the switched hot to the bulb, and then a white wire back to the neutral bus. And then to complete the circuit, we'll use the neutral from the light back down to the neutral bus. Now that I've got the neutral bus, I can connect the neutral on the NEMA 1450. Now, even though a EVSE at 240 volts does not use the neutral, I might repurpose this for something else. So if I do, I want to have the neutral on there. So I already cut a piece of heavy 6 gauge wire and bent it. So I'm going to get it through down here to the neutral bus, and then up here to that connection in the NEMA 1450. And then tighten both of those down. So now the NEMA 1450 has hot, hot, neutral, and ground. So on the contactor, it's a 120 volt coil. So what I'll do is use the hot switched output from the smart switch here onto this connection, and then the other end of the coil, just a neutral wire back to the neutral bus to complete the circuit.
So is that what you missed? Because you said I realized I missed.
I crimped on a solderless female spade connection, plugged it onto the coil connector on the contactor, and brought the other end down to the neutral bus bar. So here is the actual switch I'm going to use for this project. It's a Leviton Decora Smart. This one uses Z-Wave. It does require a neutral, and it is compatible with the Samsung SmartThings system. So if we just open this up, there we go. So this is a Z-Wave switch, DZ15S. It's a 15 amp smart switch. So I'll hook up the hot, neutral, ground, and then the switched output is going to go to the contactor. Cool. So the switch is going to go right in this hole here, and what I need to do is connect hot to hot, cool, neutral to neutral, and then that red switched hot output is going to go to the coil here, and then 2 screws to mount it down into place. So I'll use some spade connectors onto a couple short pieces of wire. So I just added the short wires to the back of the switch. And then if I pop the switch down into place here, and what I need is the green ground wire is going to go right over to the ground bus. White neutral wire is going to come down here to the neutral bus. The black hot wire is going to connect to one of these spade connectors right down under the hot. I'll put that on, push that in. The red switched hot is going to the contactor. So I'll make the ground and neutral connections, put the screws in to hold in the switch, and then I should be able to test this. So I'm temporarily hooked up to live power, and I'll press the on switch. We hear the contactor snap shut. Also the big green power indicator light comes on, and we've got live power now at this outlet. And if I press off, same thing, kills power here, but I want to program this to connect to my network. So just following the directions here, it says to press and hold the top paddle for 7 seconds and then tap it once after that. So we'll press and hold 7 seconds. Okay, we got that there, and then just press it once. And it turns green. And now I'm gonna, in here, I'm going to go to add a thing. And hopefully this will pop right up under devices. If it doesn't, I'll see about doing a. Ironically, right when this popped up automatically is also when my camera battery died, but I assure you, this popped up automatically. It just says Leviton switch. It also says rename device, so I'm gonna do that right away. I'm going to call it EVSE. And just save that. So now I have a device called EVSE. I'm going to hit save. And now under my various devices here, there's one called EVSE. It shows that it's on right now, and what I'm going to do is just press the button again. So now I can turn the EVSE on and off from my phone. So the next thing I need to do is put the cord through the box, and so that's got to come up to mostly to right here, and the ground and the neutral, and I want to give it some space. So what I'm going to do here is I'm not going to drill the hole in the middle because there's kind of this rib here from this screw hole, so I thought I would do it in the left half of the box but still centered. So I can do that by just drawing kitty corner on the one side and marking that. As anytime you draw from corner to corner, you can find center. So maybe you can see that X right there. And then basically the hole needs to be that big. So I'll drill that out. So I realized I did not have a drill bit or a hole saw the right size, so I'm going to try to use the circle attachment on the Dremel here again, see if I can just cut a circular hole. So now that we have a hole in there, we just got to put our cable clamp through and get the conduit ring on the other end. Then put our cable through. And now our wires here are going to have to loop up to here, 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 and here. So now this all just needs to tuck back down inside. Line up those holes so I can put the faceplate on. Then we got these little feet that go on. They can go sideways, they can be in the middle. I'm gonna do it just kind of top and bottom off the corners here. Although these screws are a little funny, they don't exactly look like self-tapping screws, but obviously they go in right here, so we'll see how well these thread. They're probably gonna be really tough to get started is my best guess. Not too terrible, but not exactly easy either. The first thing for mounting the box to the wall was just knowing where I wanted it to be, so I was going to put it right next to my 50 amp electric outlet, and also low because my daughter is only 7 years old. She's pretty short and she'll be using this, so I wanted to make sure she could reach. I temporarily mounted it with one screw so that I could get the box nice and level. I got my 2-foot level on there. And then I marked and drilled the holes as needed for the other screws. Used some nice heavy-duty wood screws. The 2 holes on the right line up with a stud, so those are super duper secure. This thing isn't going anywhere. And the screws on the left are going into nice solid plywood. And then I just need to plug the cord into the wall and turn the circuit breaker on. And then the very last thing is to mount and plug in my EVSE. So I can turn the EVSE on and off remotely through my phone, through a web page, through timers, through variables and automation. And then I also have a switch locally, manually, to turn it on and off. So all I need to do is plug in my car and I could have this turn on or off anytime I want, automatically. And then another thing that's a nice feature on this system is this little meter here, because before I really had no idea how much power my car was using while it was charging. So now if I turn this on, we get power to the outlet, and this is the EVSE is connected here. The car is plugged in, I can hear it starting to charge, and I'll see the power here in watts start ramping up. And now I can actually see how much power it charges at. I know it's around 3,000-ish watts, but I don't know exactly how much power it is. So now it looks like it's kind of leveled off. It's a little bit more than 13 amps, almost 3,200 watts. And then on the energy meter over here, it'll also track the total amount of energy that goes through here to the car. So just another nice thing to track energy. And it's well lit at night. I can clearly see that the power is on. So that's the project so far. I've experimented with using timers, works great. I'm also starting to experiment with using some other inputs. It's pretty cool that the home automation system allows you to integrate other things in to add new features. I've got some ideas for adding my solar system in with the home automation system. I'm actually about half a step away from being able to say, Alexa, charge my car. So I hope you that you subscribe so you don't miss any of the future videos. And then of course, take a look at the blog at 300mpg.org for more information on this project. And until next time, stay charged up.